Hi everyone. Today we're going to take a look at what a power series is. So before we get to that, let's take a look at this opener and we're going to go back to what we talked about yesterday, which is geometric series. Okay, so this opener says consider the following infinite geometric sum. So sigma starting from 0 all the way to infinity of x plus 1 to the n power all over 2. So if we write out the first three terms of this sequence, right, let's let n be 0. That term would be, well, x plus 1 to the 0 power would just give us 1, so we would get 1/2. And if we let n equal 1, that would give us x plus 1 to the first power over 2. I'm going to go ahead and put a 1 here as an exponent, even though we typically wouldn't. And if we let n equal 2, that would give us x plus 1 squared all over 2. Okay, so we know this is a geometric sequence, right? And so we know it's going to have a common ratio, right? So what is that common ratio, right? What am I multiplying the first term by to get the next term, this term by to get the next term? And this is why I wanted to write x plus 1 to the first, is because we are multiplying by just x plus 1, right? The first term, where n was 0, had no x plus 1s in it, so we multiply by that and it pops up in my numerator. Multiply by that again and I get an x plus 1 squared in my numerator. So that common ratio, right, r, is equal to the quantity x plus 1. Okay, now going back to what we talked about yesterday, right, how do we find the sum of an infinite geometric series? So let's go back and take a look at yesterday's notes, and if we go right back to the opener, right, and part B, right, we wrote a very important formula for us, right? The sum of an infinite series, right, for a geometric sequence where the common ratio has to be between -1 and 1 in order for this to work. Here is that formula, a sub 1 over 1 minus r. Okay, so we're going to go ahead and apply that to ours, right? But the key thing here, right, is that this x plus 1, right, in order for us to have a sum, right, x plus 1 must be between -1 and +1. Okay, so again, for this infinite series to have a sum, the common ratio must be between -1 and +1. So what that means then is we can set up an inequality, right? -1 is less than x plus 1 is less than 1. And now we can go ahead and solve this inequality for x. So if I subtract 1 on both sides, I get -2 is less than x is less than 0. And this right here gets us to our first key term of the day, right? This is what we call an interval of convergence. In order for this series to converge, right? So in order for us to have a sum for our given geometric sequence, x has to be a number between -2 and 0. This is an interval of convergence. Okay. Now, part C says to find the sum. So we're going to go ahead and assume x is in our interval of convergence. And so to find this sum, let's use that formula from yesterday, right? S sub infinity is going to be a sub 1 over 1 minus r. And so if I apply our formula, so a sub 1, right, the first term, right, now be careful here, right, you would assume that normally we would plug in 1 into our sequence to get the first term, but remember in this case n is 0. That's going to give us our first term. So we're going to get 1/2 over, let me get that straightened, over 1 minus r, which is the quantity x plus 1. Okay, so this is going to be 1/2 over, well, the 1s are going to cancel, so I'll get -x, right? And so this is going to end up becoming -1 over 2x. That is the sum. Okay. All right, let's keep going with this. So example 1 says evaluate the following sum and determine the interval of convergence. So here is my sigma notation for this infinite series, again starting at 0. So before we do anything, let's just write out some of the terms in the sequence, right? So when n is 0, my first term is 1. When n is 1, my next term is just x, or x to the first, right? My next term is x squared plus x cubed plus ... right? So what is going on here, right? What is happening here? So let's write down a couple of things, okay? So the first thing I want to write down is, what is the first term in this sequence? Well, that is 1, okay? The next thing is, well, what is r, right? What am I multiplying by to get the next term? So 1 times what gives me x? Well, the answer is just x, right? Same thing, x to get x squared, it's just another x, etc., right? This is x to the n. We're just getting one more x every term, okay? So the r value here is just x, okay? So the sum for this sequence, right? So if I follow, or for this series, if I follow the same formula as last time, a sub 1 over 1 minus r is just going to be 1 over 1 minus x. And that is going to be our sum. Okay, now, this is a very big caveat here though, right? Just like with the last one, right? This only works if x is in a certain interval of convergence, right? So just like last time, right? Whatever r is, we have to make sure it's between -1 and 1. So we set up our inequality, we solve to get the interval of convergence. Let's do the same thing this time, but this time it's going to be a little bit easier because r is just going to be x, right? And so if r has to be between -1 and +1, right? Well, then in this case, x has to be between -1 and +1, okay? And this will be our IOC, Interval of Convergence for short, or International Olympic Committee if you're excited about the Winter Olympics as like I am, okay? So that's our interval of convergence, but there's one more key term I want to talk about here, okay? So I'm going to put a big or here, and I'm not going to use an acronym for this one. I want to write it out. I want to talk about something that is called a radius of convergence. Okay, so a radius of convergence is kind of like the same idea. We're just kind of representing it a little bit differently, okay? So basically, right, think of this interval as kind of like the diameter, right? This is how far, this is the diameter for x, right? So that we can get this series to converge, right? It's from -1 to +1, right? Well, 0's in the middle of that, right? So another way I can represent this is to say from 0, how far is it to the edges where I can have a convergent series, right? So that radius I'm going to represent as the absolute value of r is less than 1, right? So I'm going to say that, remember, r is the common ratio, right? Which in this case is x. The absolute value of x has to be less than 1, okay? This is what we call the radius of convergence. And we'll see another example of this where I think it'll make a little more sense the second time around, okay? All right, we're going to call it a day right here. See you next time.